Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching your favorite series Sankalp KCET 2026. So if you are someone who is preparing for KCET 2026, then entire Sankalp batch is for you, and it is very helpful for all of you. So don't miss out on any single video. If you have not watched any of the previous videos, then you have to go back to our channel, find a playlist. There is a dedicated playlist for all the subjects of Sankalp batch. Go and check them out one by one. Now today I am going to discuss a chapter, wave optics. We have already completed up to current electricity in the first half, and then ray optics and wave optics from the second half. We will continue from moving charges and magnetism from next class onwards, but wave optics we will complete in two parts. First part is basically about wave theory. Total number of questions that you can expect from this chapter is 3, and from today's lecture you can answer 1 to 2 questions you can answer from this lecture, and 1 to 2 more questions you can answer from the second chapter. Based on the year, the number of questions from each part varies every year, but at least one question you can answer if you watch this video. This will not be a very long video, so don't go anywhere, please be seated, and also it will help you to answer questions for your board exams as well. So that is also very important, and JEE related question, basic JEE related questions also you will be able to answer. Not very difficult level questions, but easy level questions you can answer from this chapter. Now let's start. Before I start, I just want to remind you that you have to join our WhatsApp channel for all the lecture PDFs, notes, updates, etc. The link of that is given in the description of this video, so don't miss to join our WhatsApp channel. And the students, those who have followed my instructions and obviously completed all the lectures thoroughly, then they are here in our leaderboard today, and you might be there in our leaderboard next year. So that is very important for you. Don't miss out a single lecture from us. Now let us look into the chapter details. So what are all the important concepts from this chapter, what all we are going to study in the lecture. So first is wave theory, Huygens principle, coherent and incoherent light. These three things we will learn today. In our next class we will learn about superposition, that is interference of light, their intensities, Young's double slit experiment, maximum and minimum conditions, diffraction of light, and then polarization and Malus law. This is very important. Almost every year a question from the polarization is coming, and also superposition, interference of light, they are also very important. So don't miss out on the second part of this lecture as well. First we will look into the definition of wavefront, very popular topic nowadays among the teachers. So first, what is a wavefront? Understand the definition of wavefront, and it will help you a lot in understanding and answering questions in your board exam as well as KCET exam. A wavefront is defined as the surface of constant phase. Constant phase. It is very important to understand the term phase. We will explain that in a while. Just be patient. Next is the speed with which the wavefront moves outwards from the source is called the speed of the wave. So speed of the wave is basically speed of the wavefront. Now let's understand the term phase. Suppose we have a point source, right? As you can see here, we have a point source and the light is propagating in this direction. This is the direction of propagation. Now what is the meaning of surface of same phase? So if you start from this point, okay, after some time, say 1 second, light will travel all possible direction, right? So at t equals to 0, all the waves started from the same point, right? So they started from the same point. The light which starts at the same time, okay, from a source are called, they are in the same phase. So basically, suppose if I say that all the students who are watching my video, they are all born on the same year, okay, it need not to be true, but for now assume that. So, assume that all the students watching this video, they born on the same year, same time and same day. Okay, everyone, suppose, okay, so 10 students, suppose 10 students are watching now. So, all the 10 students, they have born on certain date, okay, say 2005 or 2007. Okay, so 2007 they all born on the same date, say 1st January. Okay, 1st January 2007, 12 p.m. all of you have born on the same date. Then we will say that all the students, those who are watching, they are actually have the same phase. Okay, they are all have the same phase. Now, after t is equal to 1 second, they all will reach at some point. They all will reach at the same point, right? So, what we will say that when we join all such possible points, we will say this is a surface of same phase. So, that represents that all the lights who are reaching here, they all started their journey together. They all started their journey together from this point P. Okay, some lights will come after them as well. So, for example, if I consider all the PU2 students, they have the same phase. PU1 students, they are not yet PU2 students, right? PU1 classes are already started. So, they are lagging in phase. Okay, they are behind in phase because they are 1 year behind you. So, if some of you are not going to pass, then they might join them, but just for a joke. But if the students who have already completed their PU and now looking for admissions in colleges, they are ahead in phase. They are ahead in phase. So, if I consider this layer, they all started at same point. So, they are phase, they are in phase. They all are called in phase. That means they all started from the same point at the same time. Okay, this one is lags, this one is lags, okay, and this one leads. Leads means ahead. Okay, this layer is ahead in phase, this one is behind phase for with respect to this. Now, all these things are called wave fronts. Okay, they all of them are basically wave front. For example, batch of 25-26, batch of 26-27, right. So, all of you are in phase, you are particularly from a batch, particular class of students, right. So, this is all of you are in phase, whoever is behind you are lags behind a phase, and whoever is forward, they are basically leading in phase. Clear? Always try to remember using real examples, that helps you to retain the concept better. Okay? So, in phase means whenever they started their journey together. Okay? So, they are all in phase, whoever is behind them are lagging behind, because every time they were moving this way, by the time this wave front moves over here, this will move here and the other one will move there. Okay, by the time you move towards your college, engineering college or future college admission, okay, the students who are studying in PU1, they will move to PU2. Whereas those students who are right now looking for college admissions, by the time you reach college, they will be already in second year of the college, right. So, they will always move ahead in the phase and you will always lag behind in the phase. That is how it will continue till some time, right. So, you have to understand that the phase is basically when everything is in the same phase, means they all started their journey together. Now, let us move on to the next part, which is very important, is Huygens principle. So, before starting with Huygens principle, I just wanted to give you some historical point of view. So, we all know that rectilinear propagation of light travels in a straight line. That was the basic property that we studied so far for a very long time. Okay, now it is time for us to break that myth. Average path of light is a straight line. That is more appropriate term. from now on. Okay. But when we are talking about light, there was a very long debate, what is the nature of light, how do light propagate from one point to another. Okay. We know that light, anything that propagates has to be a form of one form or another. Like for example, if I throw a ball, rubber ball, okay, it will travel as if it is a particle. Okay. So, air or wind, when it blows, it travels from one place to another, right, it blows in the form of particles, right. So, it hits us and we can feel it. So, it is a like of particle. So, initially the first person, obviously the father of physics, the first father of physics, which is Newton, Albert Newton, sorry, not Albert Newton, Isaac Newton. So, he assumed that light is basically like particles and he called it corpuscles. Okay. So, corpuscular theory, that is his theory, that light travels from one place to another as a form of particles, right. And that point, almost similar timeline, there was another scientist, Huygens. He said that no, light is not a particle, but it is like a wave. Okay. It is like a wave. Wave means the thing that you see in the water. Okay. The most common wave is water wave, sound wave, like that. So, but at that point of time, Newton's influence was so high that Huygens theory was not so much recognized at that point of time when he was alive. Later on, there are many other people came in and they did more experiments and realized that actually Newton was not correct for the first time maybe in his life, and Huygens was right. So, later on they established the wave theory of light, and Huygens' name stood at the first of in the list, and even though he was not alive at that point of time, his theory was taken precedent, and today we are learning about Huygens theory, even though when he was alive his theory was not so much popular and people neglected it, ignored it, thinking that how can you oppose Newton. So, do not worry about it. Even if your thoughts, your ideas are not getting activated today, you will still be able to people will still be able to remember you if you are doing something correct, which is very, very important. Doing something correct in life is very, very important than just doing random things, right. So, right now focus on your study and study completely, like Huygens did when he was doing this research. Okay. So, Huygens' idea was light is like a traveling like a wave. Okay. So, let us look into the Huygens principle. It is slightly complicated for you, but if you understand the physics, it will not be very complicated. According to Huygens' principle, each point of the wave front, so wave front we have already learned. So, each point of the wave front is the source of a secondary disturbance called wavelets. Secondary disturbance means secondary source. You can assume they are like secondary source. I will explain what is the meaning of the secondary disturbance of secondary source. This is technically correct term. You can write secondary source as well. Okay. And the wavelets emanating means emitting, basically coming out. Wavelets emanating from these points spread out in all direction with the speed of the wave. Speed of the wave means how fast the wave is moving, right, speed of the wave. Now, let us look into another part. These wavelets emanating from the wavefront are usually referred as secondary wavelets. Okay, they are not primary wavelets, they are secondary wavelets, and if we draw a common tangent to all these spheres, we obtain the new position of the wavefront at a later time. So, let us understand that. Suppose here we have a point source, okay, and light coming from here. So, light coming out from here up to this point. Okay, suppose this is the time t. So, they all started their journey together and they reached over here. Okay, after some time t, they all reached at this point. Now what? Now, according to Huygens, what he says that basically this is the source. So, source means what? You have a torch light, you have a mobile torch light, or you have a lamp. So, whatever is there, that is the source. Now, when you switching on the torch light, okay, you might say that this is my source. So, light is coming from here to the destination on the screen or whatever you are trying to observe. So, that is the screen or whatever you are trying to observe. Now, Huygens says that how do the light propagate throughout the space? That was his idea. So, first he says, okay, it is coming out of the source, fine. Now, this is the primary wavefront, this is called primary wavefront. Now, he says that any point on this primary wavefront, they acts like secondary source of light, secondary source of light. So, even though the light is coming from here, okay, this point can also be considered to be a point source. Okay, this point can also be considered to be a point source, and from this point light again try to travel in all possible direction. Okay, light will try to travel in all possible direction. That was Huygens principle. Okay, so this will also behave as a source. Now, if you switch off this light, this will no longer exist. Okay, this secondary source will also die, right. So, this has no power of its own, that is why it is called secondary source. The main power is of the primary source, the main source. This is a dependent source, but this will also emit light in all possible direction, and if you take the common tangent of all such wavefronts for each point, so this is a point, this is a point, and this is a secondary wavefront, this is called secondary wavefront, right, because this is due to the secondary source, this is due to the secondary source, that is why it is called secondary wavefronts or secondary wavelets. Okay, wavelet means children of wave, wavelets means children of wave. Okay. So, they are all secondary wavefronts, and if you draw the common tangent, you will get the forward wavefront, and if you take the backward common tangent, you will get the previous wavefront. Okay. So, if you draw the backward wavefront, you will get the backward wavefront which is lagging behind, and if you draw the forward one, you will get the after some time t, what will be the new wavefront. This was the previous wavefront, this is the new wavefront. So, this is like for now, for your class, this will be PU1 past case, and this will be your future engineering colleges, right. So, this is how you should understand this concept. So, Huygens principle was very simple actually. He says that all the points in the primary wavefront, they will also behave as secondary sources, and they will also send light in all possible direction. Now, definitely there was one flaw to the Huygens principle, that if you switch on the light in the forward direction, you will not see any light in the back side. So, this backward movement, this exact backward movement was not been able to explain by Huygens. In fact, if you see it from the sides also, the light is not as bright as it appears in the front side. So, that was one flaw. Later on, one person called Fresnel, he came into the picture and he did a correction to Huygens principle. Basic Huygens principle remains the same. He just did a mathematical correction, and from there it is known as Huygens-Fresnel principle. Okay, but that is for another time, another class. Maybe if you study physics in future, you will know. Okay, but for now this is the basic Huygens principle. Let us move on. When light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than those of the secondary wavelets. Primary wavefronts are greater than or equal to those of secondary wavelets. Primary wavefronts and wavelets are equal. Primary wavefront are larger than those of secondary wavefronts. So, always you have to remember that primary source, secondary source, they are all brothers, okay, and they all move with the same speed. Okay, they all move in the same speed. Okay, there is no difference in their speed. So, primary and secondary, they all travel or move with the same speed. This is the simple understanding. Now, shape of wavefront, very important. So, if we wish to determine the shape of the wavefront at a time say t is equal to tau, okay, we draw spheres of radius v tau from each point on the spherical wavefront. So, if basically that means a source, we are previously we have considered only point source, but in reality sources may be point source, maybe it is an extended source, maybe it is like a tube light which is a flat line source, right, or it can be an LED, LED strip or multiple LEDs. So, in that case it can be a single point source where you can take directly spherical wavefront, but if the source is not a simple source, then how can you find the shape of the wavefront? That is very, very important. We draw spheres of radius v into tau. What is v? V represents the speed of the waves in the medium. If we now draw a common tangent to all these spheres, we obtain the new position of the wavefront at time t is equal to tau. So, we will for a simple point source, all every line will be a sphere only, concentric spheres. So, that will be simply spherical wavefront. But if you take a line source, what is the meaning of line source? Line source means it has multiple points. It is not a single point source. It has one point over here, one point over here, another point, multiple infinite number of lines over here. Okay. This is the line source of light. Now, you can consider each and every point, because they are illuminating, they are giving you light. You can consider each and every point as sources, right, primary sources. Now, what you have to do, you have to consider this is the direction of light, okay. After time t is equal to tau, what distance it will travel? It will travel say 5 centimeter. So, 5 centimeter you have to draw a sphere of 5 centimeter radius. From the second source also you have to draw another 5 centimeter radius. Here also 5 centimeter, here also 5 centimeter. Now, once you are completed with the diagram, you have to draw a common tangent. That will give you the shape of the wavefront. Now, how the wavefront propagates? Now, again for that you can use Huygens principle, you can use these all such points as the secondary sources, and again repeat the process, and you will see that for a line source the wavefront is a plane wavefront. Okay, it is, you might see that this is a line, but it will be a plane because it is a spherical wavefront. Okay. So, spherical wavefront means this is the line source. Okay, this is not only a single line, it is a sphere. So, the surface will be like this, it will be a plane wavefront. For a line source, the wavefront is a plane wavefront. For a point source, the wavefront is a spherical wavefront. Very important points to remember, because based on that you might see some objective question in your board exam. Okay. Board exam MCQs are, some people think they are hard, so do not forget to understand it. So, this is just because it is a spherical wavefront, so it has a 3-dimensional effect. Okay. The plane is also not a 3-dimensional, but it will be a 2-dimensional tangent, right. Tangent means it will be a 2-dimensional thing. Okay. Tangents are always 1-dimensional less. Light diverging from a finite point source, the wavefront is a parabolic. Now, let us understand the fact, it is a finite point source. Okay. The wavefronts are cylindrical. The intensity of wavefront does not depend on the distance. The intensity decreases in proportional to the distance squared. Now, it is another concept that you have to understand. This is also from KCET exam. Now, as you are moving from a point source, so this is the source S, and you are trying to measure the intensity at some point. Now, the shape of the wavefront will be spherical. Okay. Shape of the wavefront will be spherical, it will not be parabolic or cylindrical. Point source means it will always be spherical. Now, intensity, how the intensity changes. Intensity changes if the distance you are measuring from the source, okay, and the intensity at some distance is I, then you have to remember that intensity varies as 1 by r square. Intensity varies as 1 by r square. Intensity is not constant. Okay. Further you are from a source, the intensity of light decreases. Okay. For example, if you see a very far away star, it barely you can see that. Now that star might be much bigger, and in fact they are bigger than our sun. Okay. Now why the sun appears so bright? Because it is closer to us, and not even that, if the sun is also not super close to us, it is still some miles away, 1 parsec away from us. Okay. But that distance is sufficient for us to have the useful light from the sun, right. Now intensity of the light decreases as you are moving away from the source. For example, if you go to the next planet, which is Mars, the intensity of sunlight is not sufficient, and that is now it's almost a icy cold planet. And if you move slightly forward to Venus, the intensity of sunlight is so high that it is sufficient for Venus to become a hot place. Okay. It is basically a place of gas, full of gas, and completely dry and barren. Life was not possible in Venus, neither in Mars. It is ideal, Earth is in the ideal habitable zone because the sunlight intensity is perfect, because it depends on the r square. Clear? So correct answer is option D. Now let us move on to these both questions are from KCET. Now we will try to derive the two relations, laws of reflection using Huygens principle. Students often struggle it, and these questions are common in board exams. Okay. Also conceptually these are also important. Let us understand briefly. So what is this? We have a light. Okay. There are two light beam we will consider. So light beam, suppose here we have a light beam. Okay, they all started at same point and they are falling on a mirror. They are not normal. So if they are both normal, it will not be able, we will not be able to derive it. So it will be for oblique incidence only. Okay. So for oblique incidence, what is the angle of incidence? I. So this is angle I, this is angle R. What is our target? We will try to prove the laws of reflection, mainly the laws which states that incident angle equals to reflected angle. Second law will automatically be derived. Okay. Now if you see that this is angle of incidence, this is angle of refraction. So this light is falling on this mirror at point A. When the light was falling at point A, another light, another ray of light, it is basically a beam, we are showing a beam, another light which is part of the wavefront, it makes it was at the point B. Okay. So these 2 points A and B are same phase. Okay. So imagine that after 1 year, after 4-5 years, when you are about to complete your engineering degree, you have got a job through campusing, but your friend, he is not yet got a job through campusing. He has to cover slightly more distance before he gets a job in campusing, right. But both of you are from the same batch, same class, right. So A and B both started their journey together, and they, by the time A reached the mirror, B is still somewhat distance away from the mirror. Okay. B is somewhat distance away from the mirror. Now by the time B reaches point C, which is the campusing, by the time B gets a job, okay, A already started in earning money. So he is at that point E. Okay. So now they are again at the same line. Okay. So A came here, it started, it fall at point A, it reflected back, but this line just reflected at point C. That means these 2 points are again in the same phase. These 2 points must be in the same phase. So, if you draw and join this line, you will get the reflected wavefront. This is called incident wavefront. This AB line is called incident wavefront. And this one is called, after reflection, this is going back. So, that is like reflected wavefront. Right? This is called reflected wavefront. Now, if this is the incident wavefront, then this angle of incidence will be obviously angle of incidence. Whatever is the angle of incidence for the ray of light, the same angle is made by the incident wavefront. Now, if this is the angle of refraction, then this angle will also be angle of refraction, same angle will be converted by the reflected wavefront. Okay, this is the theory, this is basic theory, can be proven using geometry, but we are not doing that. You have to remember that if the angle of incidence is I, then the same angle will be that of the angle of incident wavefront, and the same angle will be for angle of reflected wavefront R. Okay, now what is our target? We have to prove, we have to show that I equals to R. That is our target. Now, how we can do that? So, to do that, what we have to do? We have to use geometry, right? So, we will consider these two triangles, AEC and ABC. Okay? Triangle AEC and ABC. Now, if this is a wavefront, this is a plane wavefront. Plane wavefront means what? If wavefronts are plane, that means these two angles are 90 degrees. Okay? These are the wavefronts. So, wavefront means the angles will be always 90 degrees. If this is the wavefront, this is the ray of light, right? This angle is always 90 degrees. The angle between wavefront and ray of light is always 90 degrees. This is a very important lesson, very important point to remember. Angle between a wavefront and the ray of light is always 90 degrees. Just for your information, let me write it this information over here. Angle between ray of light and wavefront is always 90 degrees. Okay, this is an important point to remember. This comes from the geometry of the wavefront, and if you remember it, it will help you to do lot more in future. Now, as I said, triangle from triangle AEC and triangle ABC. Okay. First of all, AEC, this is the reflected wavefront. This is the reflected wavefront. So, reflected wavefront means what? This angle will also be 90 degree, right? So, angle AEC equals to angle ABC equals to 90 degrees. Okay, angle between ray and its wavefront. AC is common. AC is common. Okay, and AE equals to BC. Why? Why so? Suppose light takes time t. Light takes some time t to reach over here. Time taken is t. Okay. What is the speed of light? Suppose the speed of light in this particular medium is v. It may not be air, it can be some other medium. Okay. So, speed of light in this particular medium is v. So, what is the distance travelled by light from travelling from B to C? Time is t. Okay, time t. So, what is the time taken by light to reach from B to C? Time taken by light to reach from B to C is will be equals to v into t, velocity into time, right? S is equal to Vt. Now, from the definition of wavefront, we said that light from A to E also take the same time t. Light from A to E also take the same time t. So, by the time light reaches from B to C, same time light reaches from A to E. We said that that was our point. Now, speed is same. Speed same medium, it is a reflection, that means speed of the light is same. So, whatever time is taken by the light from to reach from B to C, same time is taken by the light to reach from A to E, that means the distance will be same v into t, correct. Now, from there we can say that triangle AEC is congruent of triangle ABC. Both the triangles are congruent. So, if the triangles are congruent, then what does that mean? Triangles congruent means we can say that similar angles are same. So, angle BAC, therefore, angle BAC equals to triangle ECA. Okay. So, these two angles are equal. Or what is BAC? BAC is angle I. So, angle I is equal to angle R. This is the law of reflection. This is the law of reflection. So, law of reflection is easy to derive and it can come as a 3-marker question. This is not a 5-marker question, this is easy. So, basically, it is a 3-marker question. Now, laws of refraction is a 5-marker question because it is slightly tricky and long. Okay. Now, we have to understand how to derive. The derivations we will do again in future, but if you understand right now, it will be lot more helpful for you in future as well. So, first let us understand what is happening over here. Same thing, two ray of light falling on the plane. Now, here the light, once it falls from A to reaching point A, it is going to the second medium, whereas the light at the same time when the light reaches point A, at the same time this second ray was at point B. So, first ray already reached point A, second ray at the same time it was at point B. Okay. It has not reached the destination. Okay. So, now when the light was at A, at the same time light was at B. Now, light took some time, say tau, this is the symbol of tau, light took some time tau to reach from B to C. Light took some time tau to reach from B to C. Okay. And at the same time light reached A to E in the second medium. This light is still travelling in the first medium. So, B to C is in the first medium, but A to E is in the second medium. So, what is the difference? Difference is in the speed of light. So, in the first medium speed of light is V1. In the first medium the speed of light is V1. So, V1 is the speed of light, refractive index of the medium is N1, V2 is the speed of light, refractive index is N2. Okay, there is a relationship between speed of light and N1, N2, right. We will try to use that fact. Now, let us understand something more. What is that? That is, now when the light reaches the point E, and if we draw a tangent to that point, we will get the reflected wavefront. So, this line represents the reflected wavefront. So, same thing, that BAC is the incident angle and ACE is the refracted angle, okay, and I and R are definitely not equal in this case. This is not reflection, so I and R are not equal. So, So there has to be something else that we have to do. What we have to do? First of all, we have to find the distance BC. So what is the distance BC? So light takes some time tau to reach from B to C. Speed of light V1. So what is the distance? S equals to Vt. So V1 into tau. V1 into tau is the distance BC. Now the same time tau, light reaches from A to E. Clear? Same time tau, light reaches from the point A to E. Right? So what will be the distance AE? AE will be speed of light in the second medium times the same time. Time is same over here. Okay? Time is same over here. That is the definition of wavefront, if you remember. All of them are traveling and starting, and they are traveling after some time. Time is same. Time is the only factor that determines the wavefront. Okay? Nothing else. Not medium, not anything else, only time. So if the time remains same, the wavefront will be same. No matter what is the medium, does not matter. Okay? So BC is, shape might change, shape of the wavefront might change, but the definition is says that whenever they started, if the time of their journey at t equals to 0, and then whenever they reach after some same time, they will always be in the same phase, and their common tangent will represent the wavefront. Right? So this is the common tangent, and that will represents the wavefront, refracted wavefront. Here it is refracted wavefront, this is incident wavefront. Right? Now what we have to do? We have to use triangle, but not the congruent principle. So here we will use the triangle ABC. This is the right angle, okay, from triangle ABC, okay, sine of angle BAC. Why we are taking sine? Because back of our mind we know that the law of reflection, which is also known as Snell's law, it says the relationship between sin I and sin R. Clear? So that is why we are using sine thing, not cos, not tan, only sine, because we know that law of reflection is basically talks about sin I and sin R. That is why we have taken this sin I. Now what is the value of sin I? So this is the 90-degree angle. This is the 90-degree angle, means this is hypotenuse, this is perpendicular, this is base. Adjacent side is base, okay, and opposite side is perpendicular. Now sine means some people have curly brown hair turned permanently black. Some people have. So sine, some means sine, people have means perpendicular by hypotenuse. So for sine I, it will be BC divided by AC. AC is hypotenuse, so AC, BC by AC. Okay. Now sine BAC means what? Sine BAC is nothing but sine I, right? Angle BAC is angle BAC equals to I. So sine I equals to, now what is BC? BC is V2 tau. BC is V1 tau divided by AC, right? This is sine I. Now we will use the second triangle, triangle AEC, triangle AEC. Now for this triangle, which angle we will take? We will take this angle. What is 90 degree? Which angle is 90 degree, by the way? This angle is 90 degree. This is the angle between wavefront and ray of light. So angle between wavefront and ray of light will also be 90 degree no matter what medium you are in. So this angle is 90 degree. Now for this triangle, if you see this is 90 degree, means this angle is 90 degree, means opposite side is hypotenuse. Okay, this is our angle, means this is our base and this is our perpendicular, right? This is our base and this is our perpendicular. Adjacent side is base, opposite side is perpendicular. So from triangle AEC we can write sine R. Now we are not using any time, we are directly writing sine R is perpendicular by base. Perpendicular means AE by AC. Okay, AE by AC. So what is AE? AE we have already calculated, V2 tau and divided by AC, right. Sin I, sin R we have calculated. Now we have to do sin I by sin R. Okay. Now we have to put the values. So sin I is V1 tau by AC, and because we are dividing, what we will do, we will invert it. Division means fractionally it inverted. So AC by V2 tau, right. So AC gets cancelled, tau gets cancelled, and we get V1 by V2, right. Now what we will do, we will have to reorganize it. We have to reorganize a little bit. So what is I, by the way? I is in the first medium. I is in the first medium. So what is the corresponding velocity? Corresponding velocity is V1. What is R? R is in the second medium and the corresponding velocity is V2. So we have to combine I and V1, R and V2. So from that we can say that sin I by V1 equals to sin R by V2. Now what we will do? We will multiply with speed of light at vacuum to each of the sides. So we can write C by V1 sin I equals to C by V2 sin R. Now what is C by V? C by V is known as the absolute refractive index of a medium, right. So we can write this as N1 sin I equals to N2 sin R. This is the general form of Snell's law. N1 sin I equals to N2 sin R. This is the general form of Snell's law, right. So this is also proved. So law of refraction is proved, laws of reflection also proved. So this is how you do the derivation. Because it's little complex and involve more number of steps, this comes as a 5-mark question. Generally they will say state Huygens principle, and using Huygens principle derive the law of refraction. Clear? Now wavefront for different cases. Now based on how reflection or refraction occurs, there will be different cases of final wavefront, which is very important. What they will do, they will give you this line, there will be a prism, and they will ask what will be the final wavefront. There will be 4 more images. So you have to identify how the wavefront changes when it refracts or when it gets reflected. For example, we know that when light travels through a prism, okay, it bends towards the base. So this is how the wavefront will change, because the light ray traveling through a prism bend towards the base. Okay, its shape will also, even though the overall shape will remain same, but its position will change. So this is the final wavefront. So once it travels through prism, because prism always bend light towards its base, the final wavefront will also be slanted towards the base. Okay. Now what about a convex lens? What about a convex lens? So when the light travels through a convex lens, okay, it has a tendency parallel, plane light means, plane wavefront means parallel light. Okay. So if we say that plane wavefront can also determine the nature of light, right. So plane wavefront means, if I say plane wavefront, that means all the beams, all the rays are perpendicular. So what is the type of ray that is falling on the lens? The type of ray which is falling on the lens are parallel rays. Okay, all the rays are parallel. Now when you keep a convex lens in front of a parallel parallel rays, what happens? So, convex lens will focus the light towards its principal focus, that is the definition, right. Parallel ray of light falling on a convex lens, all the rays will be focused at its primary focus, right. So, primary focus means basically it will be a inverted circle, inverted sphere, sorry, it will be an inverted sphere, all the points will be pointing towards the center of the focus, right. So, this will be the new wavefront, this will be the new wavefront, which is basically a spherical wavefront. So, if you want to convert a plane wavefront into a spherical wavefront, then you have to use a convex lens. Similarly, if you want to convert a spherical wavefront into a plane wavefront also, you have to use a convex lens. Convex lens can convert spherical wavefront into a plane wavefront as well. If you place the point source on the focus of the lens. So, let me explain that what I am talking about. Suppose I have a convex lens and I have a focus, I have a light source over here. If you keep a source, what will happen? The light will be, the wavefronts will be spherical in nature. Now, once it comes out of the lens, it becomes parallel. It becomes parallel, that means it is a plane wavefront. So, spherical wavefront initially spherical, but after refraction it becomes a plane. Okay. So, to convert a plane wavefront into spherical, you have to use a convex lens. Similarly, to convert a spherical wavefront into plane wavefront, again you have to use convex lens. What next? Now, we have a mirror, concave mirror. Again, for concave mirror, plane wavefront, plane incident wave falling on a concave mirror. Again, because it focuses light back to its focus, it will also be a spherical wavefront. Okay. And here the radius will be r by 2, that is also measurable because this will be the source. So, it will be a radius will be r by 2. Okay. In the case of convex lens, the focal radius was f, directly focal length. In case of convex mirror, it will be a radius of r by 2, radius of curvature half. Again f, obviously f, but radius of curvature half. Now, coherent and incoherent sources of light. So, we are talking about phases and phases and phases. So, based on the phase of two lights, we can classify lights into coherent and incoherent light. So, what is the coherent sources? The phase difference between the displacement produced by each of the waves does not change with time, they are called coherent sources. For example, twin brothers. Okay. Suppose Marquardt and Steve, you know them, right? Marquardt and Steve, two famous cricketers. There are many other examples, but this is one of the most common example. Now, they were born 5 seconds apart from each other, 5 seconds apart from each other. So, now throughout their life till today, one brother is 5 seconds older than the other. It will not change until they actually die, right. So, one brother is 5 seconds older than the other brother. Similarly, the one brother is 5 seconds younger than the other brother. So, that means throughout their lifetime the phase difference will remain. Throughout their lifetime the phase difference will remain, and they are basically constant. Okay. One cannot suddenly grow in age more than the other brother, right. So, they will always have same time gap. So, they are basically called coherent sources. So, coherent sources are like those twin brothers when the phase difference remains same throughout the journey. So, they started from the source, they are reaching their destination. Throughout their journey, if the phase difference remains same, it can be 0, phase difference can be 0, phase difference can be +1, can be -1, it can be 0 also, but the phase difference will remain constant. If it remain constant, then we will say they are coherent sources. So, for example, light, if you consider a laser light, okay, the laser light produces very few number of light, but they are all coming towards the same direction, and they are very highly coherent source. They all have the phase difference which is fixed, and that is why they can reach a very long distance, not like a torch light. Torch light reaches up to certain distance, not super far, but laser light, if you can point it towards the sky also, it can go long distance, right. So, laser light has a longer distance, and basically they are example of coherent sources. Okay. Incoherent sources, there is no phase relation between two waves, or phase relation does not stay constant with time. They are called incoherent sources. So, two random persons or random animals, okay, then we cannot say there is a particular phase difference between them, right. The light waves coming out from two independent sources of light will not have any fixed phase relationship and would be incoherent. So, for example, if you have two laser lights, you know that one laser light is coherent source, all the rays, it has to be ray level, okay, not beam level or source level, it has to be ray level. So, suppose I have a laser source over here, all the rays that is coming from this source, they are all super coherent, they are all super coherent, they all have a constant phase relation. Now, we have, this is source 1, we have another laser source, okay, this is also sending light in the same direction, but unfortunately these two sources will not be coherent, these two sources will not be coherent, okay. So, they are not coherent, the symbol is wrong. Coherent light can be used for a lot of purposes, we will see that in our next class, but you have to understand that whenever we are talking about any phenomena, they are basically related to coherent sources of light. For example, interference, diffraction, polarization. Polarization is not coherent, but interference and diffraction, in these two cases coherent sources of light is very important. Now, how can we create coherent sources in real life? How can we create coherent sources of light in real life? The easiest way is to take a single source and then split it into two. Okay? Take a single source of light and then you split this light into two parts, then you will get a coherent sources of light, two coherent sources of light. So, Young's double slit experiment, we will talk about that in the next class. So, there we will say two sources of light. Young's was very smart person. He take one laser source and he divided that laser source into two parts, and then he got two coherent sources of light. So, basically what is the meaning of that? Laser need not to be a point source. Okay, the most laser we use are point source, but they are called laser pointers for a reason, but actually you can create a long laser source, okay, and long laser source, all of them are obviously super coherent. So, all of them are going in the same direction. Now, if you can split that, suppose I create one opening for this, one opening for this, I will say this is the source 1, this is source 2, and because they are coming from the same parent, they are coming from the same parent. So, basically they are like twin brothers. So, because you can say they are twin brothers, they have relationship with them, and that is why they can be considered to be coherent sources, right. Now, time for our homework. Please try to solve the questions and mention the answer in the comment below, and for the PDF of this lecture, go to our WhatsApp channel. The link will be shared from time to time. We have shared those who already have the link, it is the same link. From there you can download the PDF. So, once you open the link, you can bookmark it so that you do not forget it, and from time to time we will keep on sharing for all the new students who are joining us late. So, do not forget to join our WhatsApp channel for the PDF of all the lectures that we are doing on our channel. So, this is the first question. Try to answer this and mention the answer in the comment section below. This is the second question. According to Huygens principle, during refraction of light from air to denser medium, wavelength speed increases, wavelength decreases, speed increases, wavelength and speed decreases, wavelength increases, but speed decreases. Okay, try to answer that, and if you have any other reasons, you can come and discuss in the comment section of this video as well. I will try to reply to you as soon as possible, and I will be back with the web optics part 2. Till then, bye.